Hello there. Hey, welcome to 10.5. Wow, it's hard to believe that it could be Friday already. It seems like just yesterday was Thursday. You know, the fact is, today I've been looking forward to this because we're talking about 10.5 here, solid figures. Now, I tell you what, there is no more solid figure than the one you have in front of you. Now watch, there is no rippling, there's no moving back and forth for 5 minutes. No, that figure, when you touch it, when you hit it, it just, boom, it is solid. But you know, we got other kinds of solid figures too. You know, solid figures on page 541, you can follow along with me here. You know, first off, we're talking about things that are 3D, right? So when you draw a square, a triangle, don't look at me. All right, when you draw one of those on the board, you know, it's just flat. It's on a surface, it's on a plane, we call it in geometry. But solid figures are talking about 3D, three-dimensional type figures. All right, so for instance, they have these solid figures, and I tried to make them look 3D. I'll show you how to do that in a moment. I tried to make them look 3D when I drew them on the board. And if you wonder, well, what are the dotted lines for, the dotted edges? Well, those dashed edges are supposed to be, hey, imagine if this were a solid figure, you wouldn't see that. You wouldn't see this back part here if that were a solid box. But it's there, all right? So it's just to tell you, when you draw your own solid figures, that you make those dashed lines for edges that you really wouldn't be able to see if they were real, all right? But they're still there. Well, we have what's called prisms. I got two kinds of prisms here, and there are many different kinds of prisms. All right, a prism has a polygon on top, a polygon on the bottom. You know, in other words, it has parallel, you could say, polygons in it. And that polygon could be triangles and make a triangular prism. That polygon could be rectangles, make a rectangular prism. That polygon could be pentagons, and that makes a pentagonal prism. It could be, you know, hexagons, makes a hexagonal prism. I think you get the idea here. Here I used rectangles, and there's a rectangle on top, rectangle on bottom. They're opposite each other, congruent rectangles opposite each other. And that makes a rectangular prism. Now we know rectangular prisms as simply boxes, right? Here's a rectangular prism. And it's got these rectangle here, rectangle opposite, and more than that. All right, so rectangular prisms are really common and very, very, especially with Amazon, right? They're everywhere. All right, but a triangular prism, you usually don't see those as much, but remember when we had these things and we were using them? Right, and Sir Isaac Newton used these to divide light up so he could see the light, the different parts of light, the spectrum. And so in a triangular prism, you notice there's a triangle right here, and on the opposite side of it, opposite face, there's a triangle right there. So that's why it's called a triangular prism, because on the opposite sides, they have triangles. Okay, so, you know, a triangular prism, we said, you know, it can really be useful. I can't tell where the camera is right now. It looks like it's over here. No, I think it's over here. Let's see. I'm not sure where that camera is. Well, when it comes to a triangular prism, that looks something like that. And so I drew two triangles and I connected the vertices and shaded in part of it. All right. Now, we have, with these prisms, we have, of course, different parts to them. Now, there are the faces, all right? And the faces are these rectangles in this one, the rectangular prism. And let me count how many faces are in a box. How many faces in a box? Not in the box, literal faces. I'm talking about how many of these, what we would call sides on the box, okay? So we have one here in the top. Here's the other one opposite, 2. And here's one here, 3. Here's one over here, 4. And then the front is 5. And then the back is 6. So I see a total of 6 faces. That's what we call sides, all right? Now the edges, of course, are what join the vertices. So here's an edge, 1, 2, 3, 4, all right? 5, 6, 7, 8, 9, 10, 11, 12. I see 12 edges, all right? Those are the line segments that join the vertices. How about those corners? How many corners do you see? How many vertices do you see? 1, 2, 3, 4 on the bottom part. 1, 2, 3, 4 on the top part. And I see 8 vertices. So in a rectangular prism, every box will have 6 faces, 12 edges, and 8 vertices. That's kind of what makes it a rectangular prism. How about let's try it with a triangular prism. Okay, so I'm going to count the faces first. I got 1 here facing us here, 1 on this edge, 2. All right, there's 1 in the back, 3. Then there's the top triangle, that's 4. And then there's the bottom triangle, that's 5 faces. Do you see any more than that? I mean, 1, 2, the back, 3, 4, 5. How about edges? 1, 2, 3, right? Connecting the two triangles. 1, 2, 3 for each triangle. 1, 2, 3. That's 3 times 3 is 9 edges. How about vertices? 1, 2, 3 here down the bottom. 1, 2, 3 on the top. Looks like 6 vertices. So that's, you notice that's different. 6, 12, 8 for a rectangular prism, and 5, 9, 6 for the triangular prism. All right. Now here's some other shapes. This one's called a pyramid. And what you do with a pyramid, you notice that it doesn't have polygons opposite each other. When you have a pyramid, you got one. In this case, it's a rectangular pyramid because the bottom, you can say here's a rectangle. But I don't see a rectangle on the top that it's opposite. All right. So it's not a rectangular prism. It's a pyramid, a rectangular pyramid in this case. I could have a triangle down here, and it all comes up to one point above it here, and it's a triangular pyramid. All right, so you can have a pentagonal pyramid and all those things, but you would still only have one face, one base you would call it, to it, one base of it. So, hey, let's count the faces, edges, and vertices of a rectangular pyramid then. All right, so I see on the bottom, the faces here, that bottom face, and then 1, 2, 3, 4 others. 4 plus 1 is 5 faces. How about the edges? 1, 2, 3, 4. 1, 2, 3, 4. I see 8 edges. And the vertices, 1, 2, 3, 4, and then the top where they all meet makes 5. So in a rectangular pyramid, you have 5 faces, 8 edges, and 5 vertices. All right, so here's another one. It's called a cone. Now, a cone doesn't have, again, opposite polygons, all right? In fact, a cone uses a circle, not a polygon at all. So its base is a circle, and then there's one point above it that all the points of the circle meet at. So here we have what's called a cone, all right? There's also a cylinder. Now, a cylinder is 2 circles. Here they're opposite each other. So these two figures are opposite each other, circles, and then you have the edges there, the sides, that come, actually is just a rectangle that is wrapped around it. And it makes what's called a cylinder. Now, a sphere is where you have a center, and all the points in the sphere are the same distance from that center. And so these are all 3D. Now, this is the only one that doesn't have a base. There's no circle or rectangle or triangle involved with a sphere. It doesn't have a base. Now, I got to show you one more thing. Let's practice drawing some solids. All right. So when you want to draw a rectangular prism, first thing you do is just draw 2 squares or rectangles, and I kind of offset them like that, and then connect the vertices that correspond to each other. So I connected the vertices that correspond to each other. Kind of use your straight edge to do that. Then I'm going to kind of erase the ones, or I'll make dash lines out of the ones that you wouldn't see. And that's a pretty messy one. But still, that's how you do it. You make 2 rectangles and then connect the vertices like that. How about a triangular prism? Well, draw 2 triangles that are congruent and connect, again, the vertices, and make dash lines out of the ones that you wouldn't see if you were looking at it like that. How about a hexagonal prism? Because you're going to be asked to do something like this. All right. So first I'm going to make 2 regular hexagons. So I made 2 regular hexagons, and again, I'm going really fast, but I'm going to connect this vertex to that one, 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 and this vertex to that one. Now, if you draw or erase all the ones that you wouldn't see, you get a mess like that. But anyway, that's how you draw a hexagonal prism. How about a pyramid with a square base? Well, I make a parallelogram. I know it's not a square, but you can't really do it if you make it but it would be in the real thing. Put a point above it, and then connect that point to all those vertices. and erase again, make dotted line for what part you want to see. How about a triangular base pyramid? So I draw a triangle at the bottom, put a point somewhere above it, and connect that to the different vertices in the triangle, and then erase the ones that you want to erase. A cylinder? A cylinder is two ovals, and then connect the sides like this. So you make a cylinder. A cone, make one oval, set a point above it, and connect down to it like that. Now you can do this, you can practice drawing the solid figures and follow directions about finding the faces, the edges, the vertices, and you can also just imagine these 3D figures. Of course, you got to use your imagination when you draw them, especially when I draw them over here. Hey, have a great weekend. We'll see you Monday, all right? Bye-bye.